This is the solution for the ACT practice problem worksheet on solving systems of equations. If you need additional help on solving systems of equations, Textbook Tactics offers several instructional videos on the subject, the first of which is found underneath the Algebra 1 subject. The chapter is Systems of Linear Equations and Inequalities, and the sections are Solving Systems by Substitution and Solving Systems by Elimination. There are also additional videos underneath the Algebra 2 subject. The chapter is Linear Systems and Matrices, and the section would be Solving Linear Systems Algebraically. Finally, there are additional videos underneath the Pre-Calculus subject. The chapter is Systems of Equations and Inequalities, and the most important section for this test will be Systems of Equations with two linear variables. You may also want to watch the systems of equations with three linear variables and the systems of equations with nonlinear equations, because once in a while these subjects will show up on the ACT, although typically most of them are only two linear variable equations. So now let's look at the first problem on our worksheet. Problem 1 asks us if x minus y is equal to 5 and x plus y is equal to 5, then what does y equal? Well, just looking at this, I'm going to guess that y is equal to 0. Because if I have some number and I subtract a different number and I get 5, and then I add that same number to x and I still get 5, that means y is not having any effect on this equation. Doesn't matter if I subtract it or add it, I get the same number. But if you can't see that, we can solve these two equations. It's probably easiest to use elimination. If I have x minus y is equal to 5 and x plus y is equal to 5, then I can add these two equations vertically. X plus x is 2x, negative y plus y is a 0y, and 5 plus 5 is 10. This simplifies to 2x is equal to 10, and that means x is equal to 5. Now I solve this for x, but I want the y value. So I have to take this x value and plug it back into either one of these equations. If x plus y is equal to 5 and x is equal to 5, that means 5 plus y is equal to 5. Subtract 5 from both sides and y is equal to 0. And that means our answer is B. Now let's look at problem 2. Here we're told that given x is an integer, for which of the following values of x is x plus 1/4 x greater than 14 and x plus 1 is less than 14? Here I have two inequalities. The first one, x plus 1/4 x has to be greater than 14. This first x in our inequality has a 1 in front of it, but I can also treat that as 4 over 4 times x, and then plus 1/4 x needs to be greater than 14. Now I combine my like terms, because this means that 5/4 x must be greater than 14. And now I want to multiply by the reciprocal of 4/5. And this means that x has to be greater than 11 and 1/5. Now let's look at our other inequality. Here we know x plus 1 has to be less than 14. If I subtract 1 from each side, I get x has to be less than 13. So x has to be greater than 11 and 1/5, but less than 13. We need to determine if any of our answers fall in the region between 13 and 11 and 1/5. 10 is less than 11 and 1/5. So A is incorrect. 11 is less than 11 and 1/5, so B is incorrect. 12 is greater than 11 and 1/5, so that satisfies this one. It's also less than 13, so it satisfies that one, which makes me think C is going to be our correct answer. But we can check the other ones as well. D is not less than 13, so that's incorrect, and 17 is not less than 13, so that one's incorrect, so C is indeed our answer. Now let's look at problem 3. Here we're asked, which of the following equation expresses z in terms of x for all real numbers x, y, and z such that 4x squared is equal to 2y and y squared is equal to 8z. Now looking at our answers, we have z is equal to a bunch of numbers with an x variable, or z in terms of x. So we need to use these two equations to get z in terms of x. Well, which one of these equations has a z in it? It's this one. So y squared is equal to 8z. Now if we want z in terms of x, we're going to have to get rid of this y. So we need to know what y equals. We can use this other equation here. 4x squared is equal to 2y. If we solve this for y, we'll know what y is equal to. If I divide both sides of this equation by 2, I'll get y is equal to 2x squared. And then I'm going to substitute this 2x squared into our other equation, 4y. So that means that 2x squared is equal to y. But here y is squared, so we're going to square that. And this is equal to 8z. Now when I square 2x squared, I have to square the 2 and the x squared. So I'll get 4x to the fourth is equal to 8z. Divide both sides by 8 because I want z alone. And we'll get 1/2 x to the fourth is equal to z. This is answer D. Now for problem 4. If 5x plus 4y is equal to 19 and 2x minus 3y is equal to 3, what is the value of x plus y? To solve this problem, I'm going to use the method of substitution. I'm going to take this second equation, 2x minus 3y, and I'm going to solve it for y. So I'm going to add 3y to both sides. I'll get 2x is equal to 3 plus 3y. I'm going to subtract 3 from both sides, so I'll have 2x minus 3 is equal to 3y. And divide everything by 3, so y is equal to 2x minus 3 over 3. Now that I've solved this equation for one of the variables, I'm going to plug this value in for y into our second equation, 5x plus 4y is equal to 19, because y is equal to 2x minus 3 over 3. So this first equation is going to become 5x plus 4y, but again y is equal to 2x minus 3 over 3, and all of this is supposed to be equal to 19. Now we just have to simplify and solve for x. So we have a 5x, and if I multiply this 4 in, I have to distribute it across my numerator. So this is plus 8x minus 12 over 3, and that's equal to 19. If I distribute this 3 in the denominator, I'll have 5x plus 8/3 x minus 4 is equal to 19. I'm going to add 4 to both sides. So I'll have 5x plus 8/3 x is equal to 23. Now 5 is the same as 15/3 x plus 8/3 x is equal to 23. And since these have a common denominator now, I can add the numerators and combine my like terms. This is the same as 23/3 x is equal to 23. Multiply both sides by the reciprocal of 23/3, which is 3 over 23, and you'll find that x is equal to 3. So I have my value of x, now I just need to find my value of y. And to find that, I can plug this value of x into either of my original two equations. I'm going to use the second one. So if I plug in this value of 3 into our second equation, I'll have 2x minus 3y is equal to 3. Now I'm going to plug in 3 for x, so I'll have 2 times 3 minus 3y is equal to 3, or 6 minus 3y is equal to 3. Subtract 6 from both sides, and I'll get negative 3y is equal to negative 3. Divide both sides by negative 3, and y is equal to 1. So I have my value of x, and I have my value of y. If I add them together, 3 plus 1 is 4. So our answer is A. Now let's look at problem 5. Here we're told that if x is equal to 4y, y is equal to 1/3 z, which of the following is the value of 2z minus x? If I take this value of y and plug it into this equation, I'll have x is equal to 4 times 1/3 z, or x is equal to 4/3 z. Now I know what x is equal to in terms of z. So if I plug this into here for x, that would mean 2z minus x is the same as 2z minus 4/3 z. Now, 2z is the same as 6/3 z. So if we subtract 4/3 from 6/3, we will get 2/3 z. So 2z minus x is equal to 2/3 z, and that's answer C. So now let's try problem 6. Here we're asked if x and y are positive integers such that the greatest common factor of x cubed y and x squared y cubed is 64, then which of the following could x equal? Well, let's find the greatest common factor of x cubed y and x squared y cubed. My factors of x cubed y, well, they're x, 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 and y, all multiplied together. My factors of x squared y cubed would be x, x, and then 3y's, all multiplied together. My common factor would be 2 x's and a y. So x squared y is equal to 64 because x squared y is our greatest common factor, and we're told that that is equal to 64. So now we want to know what x's could be equal to. Let's look at our answer choices. Here A is 3. If x is 3, then we'll end up with 3 squared times y is equal to 64, or 9y is equal to 64. If we divide both sides by 9, we'll find that y is equal to approximately 7.11. Remember, x and y have to be positive integers, and 7.11 is not an integer. So A is wrong. Let's try answer B. If x was 4, then our greatest common factor would be 4 squared y, and that would be equal to 64. Now 4 squared is 16, so we'd have 16y is equal to 64, and if we divide both sides by 16, we get y is equal to 4. So here x and y are both integers. X is 4 and y is 4. So it looks like B is going to be our solution. But we can try a couple more just to double check. Let's check answer C. It says x should be equal to 5. Well, in our greatest common factor, that would mean that we'd have 5 squared y is equal to 64, or 25y is equal to 64. If I divide both sides by 25, y is equal to 64 25ths, which again is not an integer. So C is incorrect. If I plug in 16 for x, I'll be squaring 16, and that's well over 64, which is going to make y a fraction again, and the same thing with E. So B is our answer. Now let's look at problem 7. Here we're told a large sphere has a radius that is 3 times larger than the radius of a small sphere. How many times larger is the volume of the large sphere than the volume of the smaller sphere? And then we're given the equation for the volume of a sphere. If we call the radius of the small sphere x, then the radius of the larger sphere would be 3x, because it's 3 times larger. Now we're going to create two equations. The volume of the small sphere is going to be equal to 4/3 pi r, where my radius is x, so x cubed. The volume of my large sphere is going to be 4/3 pi 3x cubed, because the radius of my larger sphere is 3x. If I cube 3x, I'll get 27x cubed. So this is equal to 4/3 pi times 27x cubed. Now if you look at these two equations, they both have a 4/3. So let's drop the 4/3. They both have a pi, so we'll drop that as well. And they both have an x cubed. So if we reduce all of these, then the ratio of the small volume versus the large volume should be 1 to 27. So the larger sphere has 27 times the volume of the smaller, and our answer is E. Problem 8 asks us, if x is equal to 3t minus 6 and y is equal to 3 minus 2t, which of the following expresses y in terms of x? So we need an equation with just y's and x's. We've got to get rid of these t's. The easiest way to get rid of a t is to solve one of these equations for t and then plug into the other one. So let's take this equation here, y is equal to 3 minus 2t, and solve it for t. Y is equal to 3 minus 2t. If I subtract 3 from both sides, I'll get y minus 3 is equal to negative 2t. Divide both sides by negative 2, and t is equal to y minus 3 over negative 2. Then we're going to take this value for t and plug it into this first equation. So if x is equal to 3 times t, x is equal to 3 times y minus 3 over negative 2, and then minus 6. Now I want to simplify this, so x is equal to 3y minus 9 over negative 2, and then minus 6. So this should be my solution, except all of the solutions in this problem are given as equations where y is equal to a bunch of numbers involving x. So we're going to have to rearrange this and solve this for y. And to do that, we want to get our y term alone, so I'm going to add 6 to both sides. So I'll have x plus 6 is equal to 3y minus 9 divided by negative 2. Now I'm going to multiply both sides by negative 2 and get negative 2x minus 12 is equal to 3y minus 9. Add 9 to both sides, and you'll get negative 2x minus 3 is equal to 3y. And then divide both sides by 3, and you should find that y is equal to negative 2/3 x minus 1. And that is answer C. Now let's try problem 9. Here we're told that 3 friends are going to rent a house to live in. If they split the rent 3 ways, each one of them pays $650 each month. They were hoping to each pay $400 or less. How many more people have to live in the house for each one of them to pay $400 or less? Well, let's call y the total rent. And let's call x the amount each person pays. Now we're going to make 2 equations. The first equation, our total rent, y, is equal to $650 times the number of people. The other equation is y is equal to $400 times the number of people. Except in our first equation, when everybody's paying $650, we know x is equal to 3 because they're splitting the rent 3 ways. So the total rent then would be $650 times 3. That means, in this case, y is equal to $1,950, or the total rent for the house is $1,950. Now let's take this value of y and plug it into this second equation. So we'll have 1950 is equal to 400x. Divide both sides by 400, and x is equal to 4.875. or 4 7/8. So we found out that the friends are going to need 4 7/8 amount of people to live in their home for their rent to be $400 or less. Except you can't have 7/8 of a person, So actually they're going to need 5 people to live in their home for their rent to each be $400 or less. But the question doesn't actually ask us how many people have to live in the home. This is a common mistake. The question asks us how many more people will have to live in the house for each one of them to pay $400 or less. Well, there were 3 of them initially, but we found out that they're going to need 5. So 2 more people, 5 minus 3, are going to have to live in the home. And our answer is E. And now for our final problem, problem 10. Here we're told that 10 players from the high school soccer team and 8 players from the football team donate money for a senior class gift. The soccer players each donated half as much as each football player, and together they raised $260. How much did each football player donate? Well, let's call X the amount that the soccer team donated per person, and Y is the number or the amount that the football players donated per person. That would mean that 10 times the number or the amount that the soccer players donated plus 8 times the amount that the football players donated, or Y, has to be equal to the total of $260, because there are 10 soccer players and 8 football players. So we have one equation. We also know that the soccer players donated half as much as each football player. So X has to be equal to 1/2 Y. If I take the amount that the football players donated and cut it in half, I'll find the amount that the soccer players donated. So now I have my second equation, X is equal to 1/2 Y. To solve this, I'm going to plug in this value of X into my other equation. So I'll have 10 times 1/2 Y plus 8Y is equal to 260. Now 1/2 times 10 is 5, so this is 5Y plus 8Y is equal to 260. 5 plus 8 is 13Y is equal to 260. And Y is equal to 20. Y is what we wanted because we wanted to know how much each football player donated. Well, the answer is 20 or $20.